prove that there exists a power of 2 that ends with the digit 001. This is actually a very general problem, and you can modify this problem to different powers of different numbers depending on your solution, and then arbitrary number of zeros, I guess. So for example, so the question says that there is a power of 3 like this. When you calculate this power, you will get something like this, the numbers, and then it will be like 0, 0, 1. So what does this mean, 0, 0, 1? It means that when you divide this number by 1000, you will get remainder 1, right? So like if it was 0, then it would be divisible by 1000, but it has 1, so it has 1 remainder. So we are looking which means we are looking something like this. We are looking for some k which would give us remainder 1 when divided by 1000. So this notation means if you divide 3 to the k by 1000, you get remainder 1. So now let's look at the powers of 3 from 3 to the power 1, 3 square, 3 cube, and up to 3 to the power 1000 and 3 to the power 1001. So we have 1001 numbers. And we are trying to divide by 1000. So like if you divide all these numbers by 1000, when you divide a number by 1000, the possible remainders are from 0 to 999, right? So there are 1000 possible remainders, but we have 1001 remainders numbers here in this list, in our list. So what does it mean? It means by Dirichlet principle there are two which have same remainder. So which means we have some 3 to the power m and 3 to the power n. They have same remainder when divided by 1000. So this means like they have same remainder. So since they have same remainder, 3 to the power m minus 3 to the power n will be divisible by 1000, because the remainders will get cancelled out. So if we assume that m is greater than n, you can just take out, you can rewrite it as like this: 3 to the power m minus n minus 1 is, okay, so let me fix this, 3. So that's divisible by 1000. So 3 to the power n, this is the prime factors are only 3. It's a product of 3's. 1000, so 3 to the power n, and 1000. So that's like 2 times 5. 2 times 5, 2 times 5. They are relatively prime numbers, which means you cannot divide 3n by 1000. So it means this part should be divisible by 1000. So from this statement, we can see that 3 to the power m minus n minus 1 is divisible by 1000. So from here, we can see that 3mn has remainder 1 when divided by 1000. So if you calculate, so this gives us the desired k. So k is m minus n. So which means if you just look at all the powers of 3 from 3 to the power 1 to 3 to the power 1001, there will be one which ends in 001. So we don't know which one, but there is one. So you can just increase number of zeros here, or probably use powers of 7 or some other number which is relatively prime with 1000. So probably you can use any number which doesn't have factors of 2 or 5 here, and then modify the problem like to have like an arbitrary number of zeros here. So that kind of proofs completes the proof.